Hello once again, it's Mr. Pete, your YouTube shop teacher, and this is part 2 of my build on the little Peterson Products aluminum drill press vise. Be sure and go back and watch part 1 if you have not already done so. So what I'm going to do in this part is drill and tap the hole right here for the screw, but I believe I'll make the screw first. Now remember, there's no dimensions for this, no drawing, so everything is just off the top of my head, and I'm trying to scale this down and really determine what size thread I should use. And looking at this little palm grin here, it's just a little bit bigger, but this is a 3/8 screw made from, I believe, 1/2 inch stock with a 3/16 diameter handle. I want to go just a little smaller than that, I think, and I'm playing around here with different screws and trying to scale it in my mind. But this is a piece of 5/16 all thread, and to me that just looks like a good proportion. And the end of it, of course, will be turned down like this, and a hole drilled in here as well. I'll talk more about that and how I'm going to drill this a little later in the video, but let's get started on the screw. Now this is 7/16 diameter 12L14 screw machine stock, and that's what I'm going to use. And I need to turn it down, again no dimensions, I just laid this across here as such up to the line, and then later the end will be turned down like this. But what I'm doing here that's a little different, and by the way, I will thread this, power thread it on the lathe using a die. I'm not going to single point it to expedite things here, but I'll be doing something a little different in that I will be using the Eccentric Engineering brand of diamond tool holder. See the name, Eccentric Engineering? Diamond tool holder, and I have two of these, a right and a left. This is the one, I'm not using this one, I have the other one already set up in the lathe. They call it diamond or tangential, kind of a tongue twister. It looks like a diamond from this view. Gives an extremely beautiful finish, easy to grind, and this is my inaugural run, and this was given to me by a man from Australia. These are made in Australia, and his name is Peter Probst, and here is the data sheet on that. So that's what I'm going to be using. There's some ordering information, but it's also available in the United States, I believe, without paying the extra shipping. So let's step over to the lathe. Alright, here's the setup on the lathe. Here's the diamond tool holder. I'll be using a power feed. Notice that I'm using a half center. It's a dead center, but it's a half center with the CMD lube so that I can get in there. But remember, I'm just taking it down to 5/16 diameter. So I'll take several passes. I won't show all of that up to the layout line there, and I have a carriage stop that is set. And now I'm turning the end down to 1/4, 1/2 inch back. That's the part that will go in the movable jaw. I have the 5/16 18 die and a die holder held in the tailstock Jacob's chuck. Back gear, slow speed, plenty of oil. Now, this die will leave a trace of a thread on the 1/4 inch, this being 5/16. And now a nice cross hole in the handle using the Heinrich cross hole jig. And now cut off and face to length. Alright, the screw is finished, except of course for the handle and a little slot there for the set screw, and I'll do that later on after I determine the location. But next, let me drill and tap this hole. But it'll be in the center this way and the center this way, height-wise. Not the center of this piece, because that's way too high and still has to be trimmed. Now, in preparing the setup for drilling and tapping the hole here, it could be done in this big vise, holding it like this, squaring it up real well, and it would get squared up in one axis against the jaw, and that's a good way to do it. But the way we did it in the high school was with an angle plate, because of course we had vices that were larger, and with the larger vise you have to drop the table so far down so you have room for all of your different cutting tools and so on. So instead of doing it with the vise, and you see this raises it up at least 2 inches, I'm going to use this little angle plate right here. So let's go over to the bench and I'll show you how I'm going to set that up. And I'll slide the vise off to the side and simply clamp the angle plate directly to the slotted table. And this can be done on the drill press. I emphasize there's so many different ways of doing things. Also, the horizontal mill is just a perfect way to do this, and that's the way we did the larger one, because this didn't really fit too well on a Bridgeport because it's so long. So we did that on the horizontal with the work setting like this, and if this is the drill bit and tap coming in like this. So what I'm going to do is, with these 7/16 bolts here, I'm going to bolt this like this into the slot, any one of the slots, it doesn't matter, like that, and a nut and a washer on the back side, and I'll snug it up real well, and after it's just snugged, then I will square it up. Now, it's extremely important that this work be squared up real well. If not, it will jam. That is, if you do not get the screw perfectly straight with the sides and straight this way, it will jam, it will not work, it will become scrap metal. Now the purpose of this second bolt, and I had to cut a washer off to fit in there, is to bring this up against that jaw, hold that jaw in place for when I drill through both this piece and the jaw. So I'll bring that up and tighten it on the back side with this other nut. And I'm still not done. And then last but not least, since we still got just a little bit of wiggle with the jaw, I want the jaw to be pushed up against the body of the vise. And we used to do this at the high school. I really thought this out, and you know, it all comes back to me. Haven't made one of these in a long time. To just go ahead and clamp it here, and then after I drill, I have to drop the jaw out of the way so that I can run the tap in there. That's when I will take off this clamp and that top bolt. Let's go to the mill. Alright, here's the setup. The angle plate is clamped onto the table, squared up. Not sure that makes a whole lot of difference. And I've located with a small center drill my layout marks, and I then set the DRO for 0. I'm not sure if that shows up. That way, if I have to move the work out of the way, I can relocate it. That is, if I have to change tools or there isn't room for a tap or whatever the problem is. So I'll go ahead and center drill it, and then I'm going to drill 1/4 inch all the way through the main body and most of the way through the movable jaw. Okay, 1/4 inch. I forgot to tell you, I did not like the appearance of these round head screws at all, so I'm replacing them with button head cap screws, which I think have a better appearance. Like that. Don't you agree? Minor point. Alright, and I've got perfect alignment. Now what will happen if you're slightly crooked, it'll really catch up with you when you move the jaw all the way down, like in the position here. I may have made the thread a little bit too long if I go ahead and put a couple little steel plates in there. There's a little bit excess there, but I guess it doesn't matter. A lot of the other vices are that way. It's not that critical. A couple little points of clarification here. Notice that the screw here on this little vise is turned at a 59-degree angle such that it will match the angle that the hole was drilled. So I can either do that on mine or take a flat bottom, I should say bottoming drill, and bottom out that hole a little bit. Also, some people put a small ball in there. This one's of course too large. They would line up with the little center hole, but you need a jaw that's a little bit thicker to accommodate that, so that's not part of my plan. Just some different options that I'm showing you. Several years ago I built this Struck Casting Specialties drill press vise. It's a 3-part video. Take a look at the links here, if you will. Alrighty, I'm ready to make the handle. Modeled something after this. This is 3/16 rod, 2 inches long, and rather than make ends like this or thread them like I usually do, here's a couple ball bearings, 5/16 diameter. They were harder than a rock. I annealed them, that's why they're black in color. Now I'll put them in the 3-jaw chuck and hopefully be able to drill them 3/16, about 3/4 through, and Loctite them onto this piece. Well, there's one installed. Turned out pretty nice. Loctite's not quite set yet. And here's the other one ready to go. They drilled quite nicely. But I won't put that on until the final step because I still have to put this in the lathe and turn that little groove. I don't want the handle to interfere. Well, when you tighten a vise, of course the end of the screw is pushing against, but there has to be some way to hold the jaw onto the screw so that it will retract. Most vices use a set screw, and the set screw goes into a little groove. That is what I'm going to use today, but I considered using the original method that we used for Peterson Products, and that was a snap ring. Now this boy, that's a long time ago, he's got one gaping hole there, doesn't he? You can see the snap ring. And if you look at my drawings, they showed a little groove and even told you what snap ring to use. Well, the problem with that is when we scale it down, well, two things. This type of ring, you know, that has to be pushed in from the side needs all kinds of extra room. So you need a really big hole, more than just a counter bore. So that was what I was going to use, but the regular type that uses a snap ring pliers is so tiny, in other words, it doesn't scale down very well. So I'm not going to do that, but that was really my original intention, and that's a snap ring for a 1/4 inch rod. Also, it takes a very tiny tool to produce that little groove. So I'm going to go with the tried and true method here, which you see right there. Looking at this one now, you can see that's quite a deep groove there, and I'm going to pull this out and you can see that that is a dog point set screw. Now you're not going to find one of those at your local box store, I guarantee. You're lucky to find regular set screws. So what am I going to do? In stock I had several dog point. They might even be used ones. However, the point is way too long, so I'll have to cut that down. That's an 832 and that's a 1032. Well, you saw me lay that out, so I'm going to put this on the drill press and drill it and tap it to accommodate that screw that I just showed you. And remember, this is going to be cut off right about to where my fingernail is. Otherwise, that's kind of a long hole to thread. But I'll go ahead and drill and tap that right now and be right back with you. One other thing, maybe I said this already. I already turned the end of this down to 59 degrees, just a little bit to fit it in like that. Did I say that earlier? Well, how to locate the groove on the screw. I took this to the grinder and I ground the end of it flat. It had a bit of a point on it. So now, putting that in the hole that I just threaded, and this screw in there, I'm going to snug this down ever so lightly. Maybe it's already too tight. And see if I can turn this by hand and mark it. I don't think that's tight enough. And it's going to be hard to see because of the tracery of threads that's already on there. Well, that didn't work at all, did it? Let me put some better dye on there rather than just a Sharpie. Well, I did it again with a red dye on, and it did show up better. It's not great because of the threads on there, but it's really, the groove needs to be located between this point and this point. That will serve well enough to put it in the lathe and hit that with a cutoff tool, and I won't show that because it's kind of tedious. Be back in a few minutes. Okay, there's the groove. I hope it's deep enough, and I shortened up this screw a little bit, and I may have to, upon assembly, shorten this part of the screw also and then grind in a new slot. I think overall right now it's still too long, extremely tedious. Let me go ahead and put it in place and see if everything lines up. Wonderful. That's perfect. Okay, that's wonderful. It's working just fine at this point. So that will conclude this part 2. Tomorrow, in the final part, what I'm going to do is to make 2 steel jaw plates. They're going to be very, very thin, perhaps 1/8 inch stock. After they are installed, then I will proceed to mill 1, 2, 3 sides. And then it's done. Thanks for watching. Be sure and tune in when the next part is available. This is Mr. Pete 222.